you for an introduction. And good. I hope my slides are visible to all.
Yes, thank you.
Yeah. And good morning and good afternoon to all. And thank you very much for giving this opportunity to present the lessons which learned from Vembanad Lake, studying the Vembanad Lake, and discussing it in relation with the objectives of these workshops. Vembanad Lake is it's a study area which we have been monitoring, and it is there are different reasons for studying Vembanad Lake in connection with or it's a good area for studying the influence of extreme weather events on the environmental conditions and the human health. This is a Ramsar site which opens in the southwest coast of India, which opens to the Arabian Sea at 2 points, and it receives the fresh water from 6 major rivers. Nearly 1.6 million people interact with this lake on a daily basis for their livelihood and for recreation and recreation also. And there are many diseases like cholera is endemic to this region, and leptospirosis is present in this region, and E. coli contamination, the fecal contamination in this lake is always above the limits, prescribed limit, and it is connected with, or it can be linked with the non-buoyant sources of pollution from various sources. It includes the leaking septic sewage treatment systems or canal systems and tourism sectors or markets or like that. At the same time, this region is also known for, vulnerable to water-related extreme events and sea level rise or the monsoon and heavy rain we experience from June to December region. At the same time, we have very good medical facilities and the hospitals and the schools, so that the public awareness and education is much feasible. And this region, we experience, we know 80% of the impact of climate change are experienced through water, either through flood or droughts. And we also experienced during 2018, that is exactly in the middle of the study period which we conducted. We monitored the Vembanad Lake at 1 month interval from 2018 to 19. And more than apart from the being a just threat, these extreme weather events are also the multipliers of threats. In our case, we can say that this extreme weather event in 2018 disrupted the water supply systems and sanitation facilities, so that people are more exposed. They were devoid of access to clean water, and disease incidents were much higher. And coming to the disease incidents, if we take the leptospirosis as an example, during the study period, we monitored the leptospira, the bacteria in the water column in the Vembanad Lake, and we found that it is higher during November to January 2018 time. That's during the warm seasons, after the monsoon. At the same time, this leptospira was always there in a very high number. And the disease incident happened more during the September time. So there is a difference in the exposure, the disease incidence and the number of bacterial abundance peak is different. And this is basically because the high incidence of disease, we assume, that is due to the forced interaction of public with the contaminated bacteria that happens during the flood season in August, flood season or in the monsoon season. And we can see the image below. There is a disproportionate exposure of public. Mostly the working class of people are exposed to the flood water or the flash flood during the monsoon season. That makes some economic loss to them, and health issues are connected with that. And similar is the case with acute diarrheal diseases. The fecal contamination is much higher, always on a higher side in the lake, and and we observed the decontamination during the early stages of that's before the floods and the early June time, early monsoon time. The contamination was higher, and it is connected with it is linked with the the monsoon rains. Sorry, hello, am I audible?
Can hear you, but we can't see your slides anymore, Anas.
There's some problem with my Can you? I hope it is visible now.
Can see you now. Yeah, can see the slide.
Yeah, this increased incidence of E. coli or the acute diarrheal diseases is due to the fecal contamination. It happens during the monsoon season when the land drainage and the water table rises. It mixes up the septic sewage treatment systems. Because in Kerala, one thing is there, every house have its own treatment systems. I mean, the septic treatment systems. So this mixes with the water rise. And all these systems can function as a non-point sources of pollution, causing the spread of these pathogens into the lake, where it redistribute and it can cause diseases to the humans and also to the aquatic fish cultivating ponds and livestock areas which share the water color. So this becomes a major concern under the one's health perspective. And another one is the Vibrio disease, the cholera disease. This region is endemic to the cholera diseases, and we found that these Vibrios are living in association with the phytoplankton mostly, and we observe there is a relation between the phytoplankton and the Vibrio, the chlorophyll and Vibrio, so which can be monitored through the Earth observation tools, remote sensing, and we found there's a we prepared a risk map of cholera using the remote sensing and in-situ remote sensing measurements of chlorophyll. And when we go for correlating with the incidence of diseases, in all these cases, there is a clear, deficiency of high resolution data on the clinical incidence of diseases, and which is actually required. And sometimes this cholera disease and diarrheal diseases are many times they are diagnosed based on the clinical symptoms, and it is misinterpreted. So molecular tools for the monitoring the diseases using the molecular tools are important aspect which we should consider, and the integrating the environmental data with the clinical data sets are also important. And there are different species of Vibrios. Apart from the cholera, we found the vulnificus, parahemolyticus are in the system, and E. coli also. E. coli. Important point is that these microorganisms are resistant to multiple antibiotics, and that adds urgency to need to control this contamination. Inside this Vembanad Lake, it is connected with, it is being utilized by 1.6 million people for tourism and various activities, and fishing and the livestock also, right? So these pathogens can be transmitted through various routes, including its reservoirs or the the migratory birds, or even through the ballast water or the ocean transportation. So that's a concern. That's a major point to be addressed under on health perspective. So in the previous studies from our team, so it was demonstrated the importance of Earth observation data on ocean color, precipitation, floods, and sea level, with which we are able to make some preliminary risk maps and flood maps where we can give advices to the people which and prevent or reduces the impact of this extreme weather events in water-associated diseases. But we are looking forward to seeing high
That's 10
spatial
minutes enough.
high spatial resolution data and population dynamics data, or like say indicators are looking forward. And moving forward, we need a global network of stakeholders, including the scientists and the clinicians, everyone. So as discussed by Milton and Stefano, this onboard is on movement, but we need continuous monitoring of water bodies using in situ and remote sensing tools, and citizen science is another initiative which is needed, and for educating the public and participation, and they're ushering their participation in the monitoring, in which the Tower Plant Science Foundation is playing a good role. And we look forward for digital tools and then importance to have access to clinical data at high spatial and temporal resolution. So with this, I conclude. I'm sorry that I took 1 minute extra for the presentation. Thank you.